All right. Welcome back. Another week of more Haskell programming and adventure game engine, interactive fiction development, and all kinds of super awesome fun stuff like that. Hope you're well. Let's get to it. I'm going to run the build script, the file watcher. Yeah, I gotta be in the right directory, of course. And this is what our project looks like so far. And we're just kind of in the middle of a refactoring of some of the internal logic to enable some easier development of some features. So if you're just catching up right now, you can get the code here at Adventure Engine. I'm Agent Ultra. This is the agency. Welcome. And yeah, so you can like pick up a shovel, goes into your inventory system, you know, right there. Having the shovel unlocks the front door, at least in this case. So we can walk the front door, drop the shovel. Walk to the door. The door is always unlocked now and all that kind of stuff. We recently implemented the locks and stuff, so it's good to see that going. And we got special commands like saving, loading, and quitting, which we're going to do right now. Okay, so let's get to our code. Last week, we implemented a little helper function, get object by name from the world. We added the state T layer to our monad stack for the game update function. And what this is going to... It's kind of like expanded our code base at first, but what it's going to allow us to do is to compress it back down again. Because what we were doing before with the update function is we were getting the world out of the game state, passing it in into the update, which would push it all the way down to the leaves. That would update the world, and then return the record all the way back at the top. And then the caller, which is the update function, would kind of stuff the world back into the game state. Instead, we're pushing the whole kit and caboodle down, because now we want part of things along the way to be able to update the state in the call stack. So for things like adding to the event log, which is what kind of kicked this all off. And yeah, and then all the functions at the very, very bottom, the leaves of our program, are going to be able to update the world state themselves without having to be passed in and then returning a new one. They can just update the state directly and access other parts of the state if they need to, that kind of stuff. So that kind of also simplifies code a little bit at higher up in the kind of like the branches of the program, because now we're going to be able to write our verb handlers a little bit in a little bit more of a straightforward manner with fewer variable binds, which is going to be nice. And so we're going to continue on with that. Open up the engine. Haskell kitties here. Haskell kitties in my lap. Okay. So we have handle drop, look in container, and walk, I think, was at the top. So right here is kind of what I meant about fixing up some of the branches and make this code a little bit nicer. Before, a couple commits ago, we had each of these little actions would update the world and return a new world back. So we'd have to like have variable bindings for the worlds and pass them along, and then ultimately return another world to the end. And now we can just write it like this: add world log message, unlock door, move player. So almost like building a kind of little mini interpreter in a way for updating the game state from our update logic, which is nice. Okay. Yeah, so let's handle pickup now. Get object in current room. All right, we can keep going down here and keep getting rid of all these worlds. That, yeah, yeah. Forget what was I gonna do? What was I gonna do? What was I getting at here with this? Oh right, game event log. So we have emit event. That's right. Okay, so that works in the state. So we should probably have an emit event for handle walking. Let's bring up our type errors there. So we need an event. And the game events are in the rewards file here, I believe. Or did I put them somewhere else? Event. No, right here. Item picked up, item dropped. Player walked. 2. Player walked. We'll take the from location and the to location in this event. Just add a little comment for myself on that. Cool. So we'll just, if we look out for opportunities to kind of compress down the code and that kind of stuff, we'll keep doing that. I'm just going to keep adding the events for now, so it seems some fun. Ties into the rewards feature and all that stuff. So event is going to be player walked. We have exit from and exit to. Cool. I almost kind of want to tie it to, like this emit event stuff, tie it to the verb handler itself. So we don't have to like manually remember to do it. Some of these handlers can get pretty meh. But we'll see how that goes. Don't want to get ahead of ourselves here. Okay, that's moving. Otherwise, we also have to see. We have to also remember to emit it here. Emit the thing here. All right, so we're kind of duplicating a bit of code. I don't know how else we would do that right now cleanly. Okay, pickup. I think we have an event for that already. Let's commit this. Add the player walked event. Recorded to the event log when walks to another room. Okay, looks good. And pickup. I think we have an event for that as well. Item picked up. That's already emitted. Very good. Let's just make sure this is... It's an easy way we can make sure this is kind of just doubly super sure, ultimately sure this is really working. If we maybe go into the update function. We could probably just put a little debug statement here. Yeah. Well, we're gonna have to import debug.trace. And in our trace, we'll just say the event log. Show G event log. Okay. And now when I run this, I should be able to like see the walk event. I'm going to see the pickup event. We should see that in the log. We got the walked one. Yeah, but we're not getting the pickup one. And we're only getting the player walked. This one, just the one. There's two. See? Not right. No, that's not right. But what did we do? Here. This is the one. We missed another spot. Just making... Maybe we should do it in move player. And the event should be player moved. That would make more sense, I think. Move player. That's down here. Does have access to the state. Yeah, okay. We do have the exit and scope. We'll just have to change it to ext, ext. And we can get rid of that. And this one should do it now. Let me get rid of that. Yep. That should fix that. Let's try it out. Of course we can't. We've got to pick up the shovel. So that one gets recorded. Oh, it's still not getting recorded. Oh, did we rebuild? Something makes me think we didn't. All right, let's try. This should work. Let's see. Pick up that shovel and lock the front door. It's, ooh, not getting recorded at all. Okay. Yes, something is happening. I think it's because we're taking the state G here, binding it to G here. And then we're lifting and putting that state back in, and it's kind of ignoring the emit event. So we might need to fix that. That's probably what's happening there. Maybe if we put the emit event call last. That got recorded. I walked door. That got recorded. Okay, there we go. Yes. All right. That's what it was. Okay. Cool. Yeah. So I guess these world updatey functions, emit event, we're gonna have to like just be careful of like the order of operations we do, and we do have lifts and puts. The emit events, I guess, should be like kind of the last thing anyway. But there we go. Okay, so that's player walked. Let's just fix player walked. Okay, good. And pickup. Let's fix pickup. Similar thing, we have to kind of put it at the end. And that should work. Yep. And now when I pick up the shovel, it should record that. Pick up shovel. Item picked up. Walk front door. Cool. Might want to also log that we unlocked the door. That's a thing that happened in the past. Okay, let's just checkpoint here. Item picked up. Event recording. Yeah. Let's see. Look. Look could be an event we could record. You know, so that the... I don't know if a game author wants to make sure that, like, if you see something, you get some points for it. Why not? That's a thing that happened. You looked at a thing. Let's quickly just rename this to player moved. I'm going to rename player walked to player moved. And just as a general rule of thumb, when you're kind of working with event-driven systems, generally when you want something to change, you give it in the present imperative tense, like move player. And then it makes it easy to write what the event that is recorded should be, player moved. Item picked up, item dropped, pick up item, drop item, that kind of thing. Just makes it nice. They just go nicely together that way. Okay. A little hydration. Moving on. Player looked. I'm looking at things. We can look in a container. Although, let's see, we can look at an exit. And I think that's the only looks we got. Look the room again, I guess it just repeats it, so... Yeah. So I guess we could have a player looked at the exit or looked in container. Or just looked. Let's do the container. Entity ID of the container. And we could have player looked at exit. Entity ID of the exit. I'll move that back up there. Oh, we're missing a JSON instance for what? Container. Yeah, should be, I think it should be game object, I guess. But the game object ID should be a container ID. Although really, maybe it should just be object, looked at object. I think that makes more sense. Oh, looked in container. We don't have it yet, but we should have that. I'm just going to leave it look in container, looked at exit. So then when you do look in the container, we're going to emit event. There, looked in container. And do we have the object ID of it? We get the container at this level. We could do it here like this. I think this ought to work just fine. So if we looked in container here, then we do have the container ID. We have to do it up here as well. And same here. Let's look. Yeah, I kind of want to put it in do look container, don't I? Then, I'm gonna have to either pass in the container ID to it, or the type takes the container itself, which seems pretty unnecessary. Yeah, I'm gonna do it in do look in container. I'll just add the parameter. Yeah, that'll be documented enough here. Cont ID, cont. And add it here. And we should be good to go there. Cool, cool. I think it's going to compile. That should be good. Look in the Brawley bucket. And player looked in container. Cool. Okay, we'll add that. And then the next one looked at exit. And the exit ID. I think we get that from here, which we're currently ignoring, but now we can use it. Where's my adventure engine window? There we go. door. Yeah, just general look. Doesn't do anything. It's just when we look at the door. That's cool. Sweet, sweet, sweet. Handle drop. I don't think we added the event logging there, so emit event. This should have the entity ID of the game object that was dropped. Emit event. Item dropped. And it should be object ID. Boom. That. Examine. So let's add an event for that. Item examined. It's like looking closely at a game object. You can examine it in your inventory or examine it in the room. So we made the event. Item examined. Object ID. Same for in room. Cool. So we add the item examined event. Take. So taking is taking from a container. Item taken. Could even be a little bit more descriptive. Item taken from container. Into the ID. So we have the game object. The two game objects. The container. And the item that was taken when that thing happened. Let's just add a little note. We'll make it item first and then container. Took item from container. Okay, so then we just need to add that, record that event here. just down here. So made event. Item taken from container. So then it's the item first. Item ID, and then the object ID is the container. Yeah. Cool. Yeah, I think that's right. So just a quick check. Wait, it's not finished compiling yet. There we go. Let's do it. Get that shovel. Walk in that front door. We can look in the Brawly bucket. I believe there's an item in there. All right, take Brawly from Brawly bucket. Item taken from container. Item ID 7, that's the Brawly, and 8 is the bucket. That's good, yeah. Cool, cool, cool. And so let's commit that. Item taken from container event. Cool. Digging. Dug. Dug. What happened when you dug? That's what we want to know. So, you dig in a room. You might find something, you might not. So we're going to get the entity ID of the room, and maybe entity ID, list of entity IDs, entity IDs. Yeah, you can dig more than one thing, but you only get one thing at a time. That's right. So it'll be maybe entity ID game object. Yeah, that's right. So you dug in the room, and you might have gotten an item, you might not have. Okay, so in that case, let's see. We have the world here. Failed to dig anything out. You did dig, but you didn't get anything. So let's make that a do so that we can emit the event. Dug. We need the room ID. Ooh, we need the room ID. So I'm going to put that there. And nothing. Just means current room is going to have to return the room ID with it. I think that makes sense. And then we have to emit event in the case where we have successfully dug something up. Okay, so we get maybe an item. There was nothing. You succeeded, but there was nothing. Okay, well, we can emit the event here as well, I guess. Doug, room ID, and nothing as well. And in the last case, we have actually an item. So then we can admit the event here with the item ID. Yeah. Doug, room ID, just item ID. Okay. So let's go make current room. Return the room ID as well. Oh, it's world player room W. That's actually the key. So we can use that. Yeah, that should be fine. Okay. Just a quick test. So we pick up the shovel and we can just dig with it right here. Alright, we dug. We in the room 0, the one we're in, we got the item 9. The weird coin from it. Sweet. Okay, so that's that. Add Doug event. Bang. Okay, let's see. What else? What's next? Object interaction. Okay, this one's gonna be probably a little bit more complex. But not much. This is where we do unlocking so far, but there might be other object interactions we could do. So when you use an item on a container, you can unlock that container with that item. So I think the one we want to record here is going to be just the container unlocked. Container unlocked. The entity ID of the container that was unlocked. Okay, so the nothing case of the container lock, it's not locked, so you don't have to do anything. Just container lock means we have to actually do the lock. Where we have the items, we successfully unlocked it. Otherwise, we failed to unlock it. We could have one for container failed container unlock failed. What else happens in this scenarios? We also used an item to unlock the container, or at least we attempted to. So we should probably record that as well. So that's going to be player attempted to unlock container with item. And this tune has like some serious Nine Inch Nails vibes. Driver. Travelion. Nice. Man, we live in the age where Nine Inch Nails has become dad rock. I feel so old. Remember when that was like, Reznor was pretty badass, and now it's like, no, not really, I guess. At least when I mentioned to my nieces and nephews, they're like, huh, what's this? I'm like, you don't understand music. And they're like, you don't understand music. We just have to agree to disagree. Nobody understands music, really. Or do we all understand music? Who knows? Okay, so we have... Oh, the container unlocked case. We also need the entity ID here of the game object, of the item. Okay, so success case where we have the items we need to unlock it. Can emit the event. Container unlocked. We give it the container ID, which is predobj. Oh boy. It's, in this case, oh yeah, it's subject ID and predicate ID. The predicate is what you're acting on, right? So we'll do that. Predicate ID and subject ID. I believe that's how that is. So predicate ID, when we run our test game and we emit this event, that should be 8. And 9, I think, was the coin. Yeah, just have to change this to a do. Fix that up there. Okay, and then we can add the one for the failure. Okay. Do bomb and mid event container unlock failed. All right, so we pick up this shovel. Use shovel on fire. Container unlocked. Entity ID 10. Entity ID 1. Right, 10. Sorry, 10 is the fire, I guess. And 1 is the shovel. Yeah, fire 10, shovel 1. That checks out. Cool. Let's drop the shovel. Let's pick up the purse. Use the purse on fire. It doesn't work. Right. Cool. Okay, good. Let's try that over again, though. I just want to see the failure case. I think we got it covered. Yeah, okay. Sweet. Add container unlocked and container unlock failed. Events. Sweet. Killing it. And I think that's it for now. It's all the events we can record for now, because it's all we're handling at the moment. Yep. Sweet. Okay. And we got event rewards. It's our score. And all of that. Okay, cool. Yeah. And let's see what we got here. Let's squish all these together. Reword this. Yeah. So we're going to add game events to add game events. Added several game events and to the respective verb handlers. Could enumerate them all, maybe, and the message. Player moved. Item picked up. Player looked in container. Player looked at exit. Item dropped. Item examined. Taken from container. Dug. Container unlocked. Container unlocked failed. Sweet. Now, let's test out the reward system and the scoring. So we have the score function that we wrote a couple of streams ago to kind of sum up the set of rewards that are available that the game author defined in response to the various player events. Let's go check if I added any kind of test events. I think I did, but if we didn't, we're going to add one now. Or maybe a few. Let's see, front porch, main hall, shovel, purse, magic probably, coin, firelock, fire, do-do-do. Okay, I haven't defined any rewards yet, so let's just add a couple so that we can kind of take this for a drive here. Let's see. I'll just add them after the kind of like game object definitions and all that sort of stuff. Rewards. Test rewards. Okay, let's see. Well, how are we gonna add the test rewards? Actually, that's kind of the next thing. Game state. So we have the event log going. And now we need some way of knowing what the rewards are. So we can calculate our score. So we could do like this, maybe. Probably going to need JSON instances for those. And we're going to have a bunch of pattern match problems. And we'll have to parse those back out. So let's fix all those type errors. Get my list up. Bam. 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 And just add one there, why not? Jump to next. Let's go there. Next. Next. Think. Oh. Where is that coming from? Previous one? Jump to there. There it is. Last one. Okay. Cool. Oh, almost. Constructor. There's that JSON instance error I was expecting. We'll fix those in a second. There's a couple more of these. Good, okay. So let's just derive those for event reward and That should compile. Yep. Okay, we're good there. Yeah. Let's checkpoint. Let's see. Pepe. Yes, 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 yes. Yep, 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 yep. I like all those. I like all those. I like them. I like them a lot. We add the game state rewards. Okay, so we add the list of rewards to the game state. So add event rewards to game state. Now, we have all the parameters we need to calculate the score, I think, and display it. Ooh, I should probably also remove debug.trace. Mm-hmm. I don't forget how I had that formatted before. Kind of like them all lined up like that. Anywho, yeah. So just remove trace. Clean that up before we push. Yeah, so now what do we need to do? We need to display, we can display the score, I believe. I don't really have a widget for that in the UI yet. Where should we add that? I feel like it's something you should probably always kind of like know about. Like your score and your holding. It's maybe like just above here on the right. Let's see if we can do that. Ta-da. Build UI. So if you're just joining me for the first time in this project, we're pretty far along. We're using a library called Monomer to build the UI. Monomer is similar to, at least in architecture, to the like Elm architecture, if you're familiar with that. It's basically like you got a tree of widgets, and you use kind of like event message passing type stuff to communicate stuff between widgets and the state. So we do that here where we build the UI. We build up the tree of widgets, and they all kind of like render their stuff from the current state. So the view area, the game view area is the it's got the rendered view stack and the inventory, which is the stuff on the side. Render inventory. VStack. Yeah, so we can put another... A VStack is just a vertical stack of widgets. Probably put another one here. And I probably want to display the score. Oh, it's going to take a list of properties. Yeah, that's right. Not enough arguments. Yeah, the type error list isn't going to be very useful in this module, unfortunately, due to reasons. Okay, so the game state here is, let's see, we got how do we get it in scope? I could pass it in as a parameter. Or instead of trying to, yeah, keep the poor old rent inventory as it is. We should probably separate them actually. Yeah, that's probably better. This whole side thing could be moved up here. The VStack could be moved up here. Maybe like this. It's a list of widget nodes it's going to return, I believe. I think that's what it will be. And then we can just, yeah, we can move it up here. That should still compile. Okay, and then we can render the score. Just a precedence issue there. Yeah, okay, cool. Render the score from the model. Or could even do it like this. Render score, maybe? That would be a label. That's like that. Not lovely, but label. Which is happy. Okay, and then wrap that up here. We can show the score. I believe it takes 2 parameters. And we go to the rewards. In here, let's see, score, yeah. List of events, so we just got to pull out those out of the model. And that'll be model game events and model rewards. Just events. I just named it something. The auto-generated lenses. No, I called it event log, didn't I? Oh, where did I put it? Game state. Yeah, I called it event log. My bad. Event log and rewards. Okay. Those are fine. So we just need to import score. And the problem here is probably what? Text with string. Right. So we got to pack that into text. T.pack. What did I do? Hey Declan CD, how's it going? Welcome to the stream. How you doing, friend? Let's see. Is it a parentheses issue? That seems to be. Okay, cool. All right, let's see if our scoring works. Oh wait, we got to add some to our default pretend game. Okay, cool. Great. Making some progress on the scoring and reward system in this game engine. Tonight, we're just hooking it up to the UI to test it out and take it for a spin. Had some good weather today. Pretty alright day. Okay, so it's kind of like our test game world. Let's add to the default world. We have empty here for our list of rewards. Oh no, that's different world. Default world, the game state. Our initial game state. Here we are, down here. Yeah, so let's add a reward for an event reward, sorry. An event reward for picking up. Item picked up. Let's just get a score for the shovel. Item picked up. The shovel, I believe, is item 1. And so I need for that, and we'll give it 10 points. Has to be an entity ID. Right. Yeah, there we go. That should compile. Okay. And there we go. All right. So this is our game engine running in a nice graphical GUI using a library called Monomer, available in Haskell. And there's our score widget we just added, just above our inventory here. And if I pick up the shovel using my pickup verb, I should get 10 points there. And lo and behold, I do. Sweet. Now, if I drop the shovel and I pick it up again, it should stay at just 10 points. It should only count it the first time. And it does. Perfect. Yes, we did it. Okay, let's add a couple more rewards to make sure that it's all summing things together just rightly. Okay, so we have an event reward for, let's see, Doug. Doug happens in the room. 0 is the entity ID for the room, the starter room, where we can dig in. And when we get the coin, which I believe is object ID 9. Let's give the player 3 points. Something a little bit odd, just to make sure that we know we're adding things up right. Cool, so that compiles and works. Okay, so now you can pick up the shovel. You can dig in the room. You get a weird coin, you get 13 points. Boom. That's what we expected. We can dig again, but nothing seems to come of it. Our score stays the same. We're good. Alright, drop the shovel, pick up the shovel. We even have aliases. You just do P of shovel. There's no shovel here because I haven't dropped it yet. Do. Just drop it, there you go. Cool. So let's commit that. When this changes applies, it'll add the score widget to the UI. Boom. Cool. I'm gonna rebase this a little bit here just to clean that up. We'll squash that in. There. Sweet. Yeah. So basically that's the idea there now. Be able to author, when you author your own game content with this engine, we can now serialize out the event rewards. So you'll be able to write out the event rewards for different things that happen in the game world when the player does certain actions. You can give them 10 points, 15 points, whatever you want. There's only one other thing I was thinking of for rewards, and that would be like completing a sequence of these things. So maybe you get, once you figure out a particular puzzle, right, you unlock this container, you get this item, and this and this and the other. You know, maybe you want to get some bonus points, like maybe 100 points for that or something. That would be a little bit trickier to model. kind of, yeah. I'm making like just a small example game with this, so I don't want to get too crazy with it. The whole idea of this project is, and the stream in general, is just to show like non-trivial Haskell projects and what it's like to work on such a code base, so that we can see things like how refactoring works in the language and different application patterns and stuff like that. So yeah, this game kind of started off more as like just a demo of like how to make it a text adventure game, and it grew into adding a GUI on the front end, and now it's kind of taking on a life of its own. But I think this is good enough, actually. As long as we have a score, this will be fine. I don't want to add to the scope. So I'm going to go to my to-do and call that the reward system pretty much done. Where were we here? Yeah, that'll be serialized out. That'll make that done. Boom. Sweet. Never used Haskell. Oh, cool. So what caught your fancy about jumping in on the stream here? Interested in Haskell? If so, you've come to the right place. Let's see, what else should we work on here? We could probably do a verb autocomplete. That would be fun. Swarm Collective is regular on the stream. They suggested this a while ago, so that's awesome. Yeah. Maybe it's time to do verb autocomplete. That's a nice quality of life feature for playing. That'll be nice. Ah, awesome. Yeah, so this will be a fun little mini interactive fiction engine. So ultimately, we're going to be able to, it's going to look a little nicer. So it's going to be very data-driven, so you'll be able to author your own games with it and run it. I want to be able to add theming here so that you'll be able to make it look nicer and make it fit the style of your game. And have graphics, so you can have little background graphics for the text to hover over. Sibnull, yes, this is using Monomer. And hello. I don't know how many times I've mentioned that this stream, but if you're just joining us, thanks for joining and popping by. Yes, this is using Monomer. So it's a pretty sweet little library so far. I quite like it. And yeah, so I want to be able to add graphics to it, like background graphics, so that you can have different background graphics for your scenes and themes. And I think that'll really cap it off. We'll add some verb auto-completion and some quality of life play features. I would really like there to be accessibility if we were going to like take this to be like an actual maybe engine for a more commercial style release, but we'll see if our attention can last that long to get there. It probably, I think SVG would be nicest because it would scale easier than bitmaps, but we'll see what's easier to support. That might be a little bit tricky because the library that Monomer is using to render is SDL2, which is rendering on OpenGL. So this is just like a texture. And so it would be not impossible to do SVG on it, but it would be a bit trickier. I don't know if there's any like libraries for that in Haskell. There might be in C, which is not too hard to bind C from Haskell, but that would be a whole thing. So we'll see. We'll do whatever's easiest. If it's bitmaps, it's bitmaps, and that's not too bad either. Okay, so let's look at autocomplete. Basically, the way we get text from the user starts off in the GUI. This is very based off of like the Elm architecture, if you're familiar with that, where these widgets and the game state transfer data through basically message passing. So the UI renders off of the game state here, and we can send input received, input entered, whatever, app input updated. So whatever the input widget gets, we can send that to the game state, and the game state has a buffer over here, input buffer, which is text. So every time we press a key, that input buffer gets updated with whatever text is in there. We should be able to take advantage of that to look at our verb alias map and come up with a couple of guesses about what the user meant to enter. Now, it's going to be a little bit tricky because I don't know how we want to display this. All right, if I wanted to type like P is a valid alias in our default alias map. That's over here. Verb alias map? Yeah, verb alias map. Right, so we can look in this map for verbs. But how do we want to render it? All right, so if I type E here, should it just jump to examine? Should it show, like, hover over maybe some options? Or kind of do some, maybe we kind of have our own input widget that kind of like has like our what we typed in, and then like grayed out behind it would be the other possibilities for E, like examine or whatever. But I'm thinking it might, the UI might be better if it was hovering over top, like the different options. I have to give more thought to that one, actually. Let's look at something else with the to-do list, because I'm running a little bit low on time. We usually finish up around 10 o'clock my time, which is about 20 minutes or so. Word wrapping. Word wrapping and world messages. That's a low-hanging bug right there. That's a GUI bug. That happens when we have really long world messages. So if I pick up the shovel and, in fact, even if I make this window smaller, no, it'll be fine. Walk, front door, exam. Oh, no, I remember the way to demonstrate this bug. Let's go back out. Examine the fire. So this text here, a roaring fire fed by some unknown source of fuel. If you look closely, there's some object in flames. Actually, that is wrapping. That's weird. Actually, I'm getting some flicker again. That's kind of one of the drawbacks of Monomer. This, oh, look, ugh. Recently upgraded the library, and it, like, I don't know if you can see this on the stream, it's looking a little better. But it's still flickering quite a bit as it's sort of trying to adjust the widget tree layout there. So it's not all roses. That's interesting. Okay, so the bug was that this bar wasn't popping up and the text was just getting cut off. I wonder if maybe it's because the scroll down bar has come up. Sand in the fire. Yeah, okay, that's still working actually. It would be nice if it wrapped though. Yeah, it's artistic flair. Thanks, Declan. Yes. Alright, so it would be nice if we could like reflow the text when it gets adjusted. And only show like the scroll bar after like a minimum size. Like obviously the widget's aware of its size because it renders the scroll bar. Oh, maybe that bug's gone. So if you pick up the shovel, use shovel on fire. We put the fire out. Okay, cool. Okay, maybe it's gone. All right, clear out that bug. I would just like to have text reflowing. That would be nicer. On widget resize. I'm gonna have to investigate that one. What else do we got? World log messages. Yeah, let's clean that up. So they're not really log messages. They're more like player messages or response messages. It's just a quick little rename here. Yeah, I like that. I'm gonna rename it to that. Probably gotta rename it in the GUI as well. Nope. Interesting. I guess I don't refer it to it by that function. Anyhow. Well, that was easy. Okay, yeah. The world log messages, that's these little kind of like messages in here. If we drop the shovel, try to go through the front door. Yeah, okay, cool. Yeah, it still works. All good. That was a nice easy one. Okay, to do. Done. else do you want to do for item object interaction? Item to item. Combine items, use items on an item. That's pretty complex. Needs more thought. Gotta get rid of those hard-coded map data and game objects as well. Yes, I do. At some point, but not today. Okay. Let's just do a little cleanup. A little cleanup stuff. Okay, so in the verbs, this is a verb-driven game. So it's not like a parser-heavy game. More like a puzzly style engine. So, in the vein of somewhat like Zork or Done It or something like that. And so yeah, so it's very verb driven. We have verb handlers. We can handle like the different pickup things, walking, looking, and all that sort of stuff. Ooh, what do we got here? Redundant bracket. Yeah, let's clean that up. And in here, I've got some fairly common patterns for things that could be refactored down a little bit. Yeah. Like this stuff here could probably be moved into something like pickup item from room, or just pickup item implying the room. Something like this. Where we have maybe the object name from the arguments. So that would be some text. And that would be a function with monad state. So yeah, some text to monad state. We throw potentially an error, a game error in that monad, and return nothing. It just alters the world. I think that's what this to-do item for myself is all about too. Potentially container verbiage. Oh, actually it might have been for picking up containers. Okay, so in that case we can probably, I think, just pull all this code up and out, and here, all the way down to there, and just have pickup item of object name. Okay, we'll need these variables as well. So put do here, pop our code here, grab these. Yeah, those all just reach into the world. I'm just kind of moving code around here. not a huge change. Of course, we need a world in scope. We know how to do that. All right, we have this pattern here for getting the state out. Yeah, we still need the G in scope as well. We need remove item and object name. Well, we get object name as a parameter. What's the problem with that one? Oh, it's shadows. Just rename it. No problem. So we just shuffled some code around there, but it means we can get rid of this. Yeah, I don't know if that really bought us a whole lot. I think pickup items only really used in handle pickup. Let's see. I'm just going to look over for a couple more kind of examples where we might be able to use something like that. Otherwise, I might just back out of that change, because, meh. Dropping items. It's almost the opposite of pickup item. It's like drop item. But again, handle drop. Pretty straightforward. Yeah. Add log, world log message was a good one. Actually, I want to rename that function now, don't I? We'll do that in a different change. Take, let's see. Yeah, that might be something common, fairly common there. I think, oh, we missed one. Missed a log message thing here that we could use. This can be replaced with the world log messages. Add a world log message, yeah. That's the one. Which I need to rename. Add world log message. Then we don't need that. Don't need that. That's nice. Same here. It just adds a message. Success message. World Prime is up here. Ah, there's one we could fix too. Yeah, that's one we could fix as well. Okay, before I get into that, this all compiles still and works, I think. I don't think we've messed any behavior up with the changes I've made so far. Yeah, I think that's fine. Just quick review. Let's see. Yeah, I kind of just shuffled that. Though that was a good change, but I think the other ones, that's a fine change. Yeah. I think the change to handle pickup could be, we should go back on that one, because like, it's just it's just moving code and adding a new name to the module. Like, it didn't really get us a whole lot. There's probably like little finer grained things in there that could be appropriate, more appropriate for factoring out. See, I'm gonna kill that hunk. Kill that. And those are fine. It should compile again. Sweet, sweet. It does. Yeah. Okay, cool. Stage those. Yeah, clean up. This is some manually added log messages. And I'll rename that as well. Do that quickly. Add player message. Yep, that should compile too. No problem. So then I'll rename add world log message to add player message. And push that up there. Okay, yeah, looks good, looks good. And then, yeah, let's look at a little bit at that code there. Handling dig. So part of that refactor is to get rid of these extra binds that we did, the refactor I did last week. We added the state T layer to push the state T layer down towards the leaves of the program. So like these verb handlers and even the helpers inside them. So like this update current room is creating a new binding for world that we have to then lift and put back into the game state here, which isn't so bad. Necessarily bad, but another one example would be like player inventory. We can probably have a helper function that just does the put this object in the player's inventory kind of thing. And then we should be able to like kind of remove those binds and just replace them with those functions. And then emit event, and that'll like just kind of clean up this handle dig handler a little bit. At least that's my theory. So let's look up the definition for update current room. Clearly takes a world in a room. So we could probably get rid of the world parameter by doing the transformation, adding the game state layer to our constraints. I would do that by just getting rid of the world parameter there, and adding monad state here with game state and m. Then let's just pull this over to the left so it stacks a little nicer. Okay, now we want to update the room, so let's make the room parameter now callback function that takes a room and produces a room. All right. Ultimately, what we're doing here right, what are we doing with the room? Well, that's right here, right? So we can just do it like this, or we can bind it in a function parameter and use the record update syntax to change it. And then we don't need the world prime bind anymore. Assuming we can do it. So W is not there. This is like the room function. I'll just call it update. And all we need to do here is get the room, yeah, up in the map here. This could even be an m.adjust now, I think. Well, we got to get the world in scope. Let's just kind of bring that in scope here. Game state. W 1 2 3 4 5 with lift get. Okay, so some of you haven't seen Haskell before. That's okay. It's pretty complicated what I'm doing. Well, not complicated, but you just have to learn. Once you learn it, it doesn't become complicated, but it's different. So you haven't seen this before. It's transformers, right? I don't know why they call it transformers, but that they call it monad transformers. So I like to think of them like stacks. And the stack's on top of the M, right? So we're stacking except T on top of this M. What is this M? It's, well, you can tell by the constraints up here that mention it. So there's a monad state layer on M, and M is also itself a monad at some point in the stack. All right, so further down, underneath the except T, there's some state. But in order to reach down into the stack, down to the next layer, you have to lift it up into your current layer. So when we're returning an except T, we're in the except T layer right now in this do block. So we're going to lift up a state operation, get, from the layer down, and get the game state out. And we're going to pull it apart here to get access to the world. And bring that into scope. We don't need that in there for dish. And so pure W, we can return the world, but we have to put the modified world back into the state. And that's kind of like what we're guaranteeing here, or the guarantee we need to hold ourselves here. So, we can lift the put operation again, G, where world rooms is equal to something, right? And it's going to be m dot update, I guess. In fact, probably that equation down there would be just fine. We don't actually have to return the world. We said it would return nothing, unit, because it's going to put it back into the state. So then, what else do we need to do here? I think we just need, so this area here, this type area here of room. It's not in scope. That's, we can bring it into scope here. Const returns a function that takes anything and just ignores the parameter. The parameter is actually room. And we haven't used our update function yet. So we'll pass it on here. What are our other errors here? Let's... Oh, we don't need dot get, sorry. We just need to lift the function. And this type of error here. Might be a similar issue. Oh, is it not put? Did I forget that? Oh, it is put. Right, okay, yeah, I remember. I know what the error is now. I think. Oh, yeah. Okay. That's the issue. I'm like, why is it looking for a world? It's so the type mismatch here is that it's looking Haskell's getting super confused right now because like I'm being silly. So like I'm trying to put a game state back into the state. The game state doesn't have this field, world rooms. It just has world. So, yeah, this was supposed to be W game state world is W where yeah, that should be in there. That where world rooms. It's kind of a nested record here. Okay, and now I'm probably just getting things mixed up a little bit. Yeah, I think I'm just getting some things. Let's this and is equal to W where yeah, that's the problem. This should be in here. There we go. Okay. So this is like another point in favor of having some more use of lenses in the engine. Because we're starting to like deeply nest things that we want to access and update. But that's our update current room function. That works. We just have a problem here. Let's jump over those. Right, so we don't have world prime prime anymore. Because we got rid of it from up here. Yeah, we can get rid of that because we use add player message for that. Get rid of that. Good. And then this problem here is we don't have a world prime prime again. So how can we get rid of this one? This one is, let's see, taking the player inventory, adding a message. Okay, well, we could just have like a helper function, a nice handy function. Like put in inventory. Monad state, game state, on M. And let's see, it will take the game object name, the item ID. That's all we really need. The player inventory is going to be able to be accessible from the game state. So yeah, that'll be text entity ID game object and returns accept T game error M and we could just do unit. We don't have to return anything. object name, object ID are our parameters. Okay. I'll just pull this out here. Pull this out here. Okay, that's going to be a W. So we're going to need the world state. So we're going to pull a world into scope. We know how to do that. G at game state. Worlds. 1, 2, 3, 4, 5. 3. Lift get. Okay. We can replace this equation with just object name and object ID. And see, that's world at there. So then we just lift put G where the game state world is equal to world. That. Just pull that a little over to the left just to make it a little more readable. Okay, and then we should be able to just call this here, put in inventory. The object name, the object, and the item ID that was used to get it, right? Or game object name. Yeah, that's the one. And then this, we know how to replace this equation. Right, we just add a player message, which is success message. There. That's a little nicer looking. I believe that will compile. And then we'll just double check that everything still works. And that'll be that for this evening. So let's dig. So let's pick up that shovel and start digging. We can dig right away here. That still works. We dug, we found the coin. We can try digging again. All right, we dig, but nothing seems to come of it, so that still works. We can walk in the front door and try to dig in a room that has no digging in it. You can't do that here, so that still works. Cool. Yep. There. So we can get, it looks like we can get rid of that binding as well. Yeah, I think that actually looks a lot nicer too. Let's just review that change. So we added update current room helper function and put in an inventory function. That let us remove these kind of extra binds in the code here and replace them with single lines of code and some even some let bindings from above too. So not too bad. Not too bad. And I think put in inventory might be useful in a couple of other contexts as well, so I feel like we're going to get some use out of that. Oh, we forgot a little bit here. We can actually get rid of this G binding. What else can we do on that? Just some little cleanup lint suggestions, couple stuff. So I'm gonna put, I'm just gonna put inventory up a little bit. It's kind of like in the middle of the verb handlers. And I'm kind of putting these sort of functions up here. Was there any, was there another one? Just check. Update current room. That's right. And I think we put that, yeah, online. We put that up in an appropriate place. Yeah. Okay. Good. Good. Yeah. Looking good. Okay. Let's stage that. Commit it. So this will refactor dig handler. Added some helper functions for putting things in the player inventory and updating room state. Okay, yeah, that's a fair bit of work we did tonight. Let's push that up. There we go. So, for those of you like Declan and Sib and stuff, just tuning in if you haven't yet, Adventure Engine is here. That's where all the code is, so you can star and follow along if you'd like. Of course, I always stream once a week on Tuesday evenings in the Eastern Standard Time Zone around 8 o'clock. So give us a follow if you like, and you'll get notifications about that if you subscribe to this stream. You could also, I also have a YouTube channel where I mainly just duplicate and export a lot of these streams there as well. Yeah, these are my recos. So it's yeah, J Kenneth King or something there. And I'm on Mastodon now. I'm moving over there from Twitter, so you can follow me at Agent Ultra at types.pl on the Mastos and the Fediverse. Thanks for the follow, Declan. Much appreciated. Growing the audience, growing the Haskell love. And that's what we got for tonight, friends. So may all your monads be free. May your types always check. Happy hacking out there, and we'll see you soon. Peace.